today's mathematics lesson. We want to look at a topic in Form 4. This is Statistics 2. This is a topic that has given some students some problem, but I want to assure you by the end of the lesson today, we are going to have agreed on how to find certain parameters. Today I want us to look at mean using assumed mean. All right. It means if we are looking for mean using assumed mean, there are other methods of looking for mean. And that's where I want us to start. And I want to tell you students that mean, normally this word mean is commonly called average. Average will imply that out of the total sum you have, you divide by the number of entry, you end up having a mean. For example, if you do a cut out of 10 in this class of ours, and the first student get a 6, and another student get a 7, another student get a 5, and another student get a 8, and another student get a 10 over 10. Those are 5 students. Now, the teacher cannot claim that he only owns the student who scored 10 over 10. He still owns the student who got 5 over 5. Therefore, the pride of the teacher will lie on the mean of this class. How do we get mean? We shall add them, 6 plus 7 plus 5 plus 8 plus 10. Then we divide that by the entry. We have 5 entries or 5 students. In that case, if you add using your calculator, possibly very fast, you'd end up with 13 plus 5, that is 18, plus 8, that is 26, 36, divided by 5, and you'll end up with 36 over 5, that is 7.2. It is correct to say that in this class, every student scored around 7 marks out of 10. This is the mean score of that particular class. Now, having told you or discussed what a mean is, we have grouped data and ungrouped data. What do I mean? I'm recapping this to take care of or to bring you to speed because of the Form 2 knowledge that we have on the mean. This is ungrouped data. It is stringed data because there are few entries, and therefore we can calculate them offhand. But suppose you have a class that has 50 students. You cannot continue listing them like this. Suppose you have a class. Today we have big classes, you are all aware. We have classes that have 80 students, like in our Form 1s. We have around 80 students in a class. How do we go about that? We need to group this data and put it in a frequency table. That said, I think now we are able to agree. And because you already know that knowledge, now let us go to the business of the day, that is to talk about mean using assumed mean. Because the other mean, we call it contemporary method, is given by mean equals summation of fx over summation f. For the purposes of my learners, this symbol, anytime you come across this symbol, it means sum. Sum of. So it should not worry you. This symbol represents sum of. Now, how do we get mean using assumed mean? That is what we want to concentrate on today. And all of us, at the end of the day, we shall have agreed that this is a good method and it is an alternative method of calculating the mean. Now, why do we work out this mean? I want to say this, that mean help, for instance, in a school, in a classroom, it helps the teacher to tell the ability of his class, to be able to compare this class with the other streams, because you are not, our stream is not alone. This is 4 Cape, for instance. We have other streams that we compete with. How can we now tell that we are competing effectively with the other classes. We can only do that by bringing or calculating the mean of our class so that we can compare that with the other classes. At the same time, we still need to do mean in other fields. For instance, our school in the intake, we are looking at the average capacity of a class versus the number of students posted in Mangu, so that we know each class will contain how many students. Such are the applications of the mean. Mean is also applied so much in the companies, in the production, because a company is able to tell which product is moving a lot, and therefore they will produce that much more than which that is not moving a lot. Having said that, let us get to the business of the day. I want us to look at a first example. I want us to look at an example here. Example number 1. Example 1. Consider, you can write it down, consider the marks of 35 students. Consider the marks of 35 students in a cut in class 4 CAPE. The scores were as follows. The marks was as follows. As follows. Now we have marks and we have the frequency. These marks are grouped. This is what I meant by grouped. I'm just reminding ourselves. 30 to 39, how many students were there? 40 to 49, how many students? Thank you. It is already projected for us. 40 to 49, we have the first category, we have 6. The next category, we have 10. And the 50 to 59, we have how many? We have 12. And lastly, 60 to 69. 60 to 69, we have 7 students. And therefore, if you calculate the sum of frequency, summation of F, you get it is 35. Now, how do we calculate mean using assumed mean using this data? Now, class, this is what we are going to do. We are going to draw this table in a portrait form so that we change the orientation. Allow me to, yes, allow us to look at our board. You have your 30 to 39, you have 6 students. 40 to 49, you have 10 students. 50 to 59, you have 12 students. And 60 to 69, you have 7 students. So you are going to include another column called midpoint. And midpoint is denoted by X. How do we get this X? I think this is important to note. How to get X? You are going to your table of marks where you have the range from 30 to 39. I want you to add those two values, 30 plus 39. You divide them by 2. The value you get there, 34.5, is your X or your midpoint. 34.5 is your midpoint. You are going to repeat that. You are going to repeat that in the next, throughout the table. So you have 44.5, 54.5, 64.5. Having filled in that column as it is on the board, you'll also include another column called D, or deviation. The column of deviation will be given by X minus A. Therefore, we need this A, and the examiner will always give us A. Why will they give us A or assumed mean? If A is, I want to give us A is 44. The examiner will give us assumed mean. A is assumed mean. Why will they give us A? Because we don't want to end up with so many different answers in the columns. We want to have harmonized work. So the examiner will give us the assumed mean, the value of assumed mean A. So we are going to fill in the fourth column of deviation. I've called it D. D means deviation, which is given by x minus assumed mean. All of us know what x is. All of us know what A is by now. So we are going to fill in that column. Let's do it using your calculator class. You're going to take x. X is already provided for. In our case, our first x is 34.5. So 34.5 minus 44. You are going to get negative 9.5. You will get negative 9.5. Repeat the same in the next column. 44.5 minus 44. 44.5 minus 44, you are getting the difference is 0.5 positive. In the next column, you have 54.5 minus 44. You are getting 10.5. In the next column, you are getting 20.5. Because you have 64.5 minus 44, you will end up with 20.5. This is our deviation. This is our deviation. Once we have deviations, now how do we get the mean? Mean is given by assumed mean plus summation of FD all over summation of F. Mean, I can say that again for the purposes of writing. Mean is given by assumed mean plus summation of frequency times density, FD, divided that by summation of frequency. So we need now to get summation of FD. It means we need another column called FD. It means that we need another column called FD. Below here, what is FD? It is frequency times density. We have frequency column and we have density, not density, sorry. It's frequency times deviation. So you multiply your frequency times deviation. In the first case, you have 6 times negative 9.5. That is negative 5.7. You have 10 times 0.5. That is 5. You have 12 times 10.5. 12 times 10.5. 126. Let me change the font. You have 7 times 20.5. 7 times 20.5. Students, I know you are following. You get 143.5. This value is 126. If you allow me to rewrite it, this value is 5. And this first value is negative 5.7. Now, having these values, then we can now calculate the sum of FD, summation of FD. And we are just going to add them straight on. 143.5 plus 126 plus 5 plus negative 5.7. And you will end up with negative 5, not 5.7. This is 57, sorry. I beg your pardon. Let's add them again. Negative 57 plus 5 plus 126 plus 143.5 plus, that's it, equals, I'm getting 217 0.5, you divide that by the entry. The entry were 35 students. If you divide that by 35, you will notice that your class mean, that gives us one part of FD, and therefore our mean shall be A plus summation of FD divided by summation of F. If you allow me to rub a part of the upper part, then class, you will notice that our mean equals A plus summation of FD over summation F, and our A is already given as 44, plus summation of FD is 217.5 all over 35. What do we end up with? This section gives us 217.5 divided by 35. That is 6.2143 plus 44. This gives you what? Plus 44. That gives you a mean of 52.214. So basically, this class in this particular cut had a mean score of 52.2. If they were to compare with their competitors, it is easily visible that this class got a mean of 52.2 marks. Some students scored above 60, but there are still some students who scored below 40. The average was found, and it is basically 52.2. Having said that, I think we have followed how to get mean using assumed mean. And therefore, I want us to do another example, if you allow me, just to emphasize whatever we have said, but I'll take it to one more step higher, because I want us to look at the variance. Because once we calculate the mean, we need to know how to get variance. And variance is calculated as, or normally written as var in short, is calculated as summation of FD squared over summation F minus summation of FD over summation F, this squared. And this is very familiar. We have already dealt with this in the past example. So whatever the increase that we are bringing in is the FD squared. I want us to consider example 2. Example 2. Example number 2. We can read the following table shows the marks of end term mathematics results in Form 3 PCT. The following table shows end of term mathematics result in Form 3 PCT. Find the mean and the variance. Find the mean and the variance if A is, find the mean and the variance if A is 50. They have given us assumed mean as 50. They want us to find the mean. If you allow me, I'll do the table in a different way for presentation purposes. These are marks. The marks will range from 30 to 39, 40 to 49, 50 to 59, as they are indicated on the slide or on the screen. 60 to 69, 70 to 79, 80 to 89, and 90 to 99. Now, this is a different class and it has more students. The frequency, which we normally write as F, is as follows, as shown in the screen: 6, 10, 12, 6, 10, 12, 15, 633. 15,633. And you get the sum of that, the sum of this frequency, you notice it is 55. The students were 55. All right. With this table, we can go ahead and get the mean and get the variance. So we are going to do as we had done previously. This is max, mean frequency. We have now the midpoint, which we are calling x. Then after midpoint, we have another column called deviation. And we are saying D is given by x minus A. Deviation is given by midpoint minus assumed mean. Once we get midpoint, deviation, we shall get a column of FD. Then we are introducing another two columns of D squared. And lastly, FD squared. These ones we have already dealt with. So we may just write them down very fast because we already know what to do. We have said to get midpoint x, you are taking 30 plus 39 divided by 2. We already got 34.5. We can see that nicely displayed. 30 to 34.5, 44.5, 54.5, 64.5, 74.5, 84.5, and 94.5. Those are our midpoints. Now, how do we get deviations? We already discussed that. We are saying it is given by x minus assumed mean. In that case, you will have them as negative 15.5, negative 5.5, then 4.5, 14.5, 24.5, 34.5, and 44.5. Those are deviations. Then we get FD. FD means frequency times deviation. Frequency times deviation. Now that column will have values like negative 93. I have calculated that for you. Negative 55. The other one is positive 54. The other one is positive 217.5. The other one is 147. The other one is 103.5. And lastly, we have 133.5. Those are FD. And therefore, at the end of the day, down here we shall have the summation, sum of FD. I need you to calculate that so that we can use it up here. Good. D squared means you take deviation, you square that. You take deviation, you square that. If you are very keen, you can do that. You take deviation, negative. Now I want us to fill the last one to save on time because this one is a column you can fill by yourself. I'm taking D squared times F. So into bracket negative 15.5 squared, whatever it is, times 6. You get 1441.5. 1441.5. The second one, you do the same. You'll get 302.5. The next one is 243. I have calculated that. The next one is 3153. That 3153.75. The next one is 3601. 3601.5. The next one is 3570.75. 3570.75. The other one is the last one, 5940. 5940.75. 5940.75. This is a column, the last column of FD squared. Now, I want the sum. We want to the sum of summation of FD squared. We add all these values and we bring them down here. We add all these values. Let's add them. Let's add those values and get the sum down there. The sum, if you work it out, you'll get 18,253.75. I hope everybody can see 18,253.75. That is the sum of FD squared. Having filled in those columns, now we come back home to what I had said initially, how to get variance. Variance is given by summation of FD squared all over summation F minus summation of FD over summation F, all that into bracket squared. So we are going to fill in those values. We are going to replace them here as follows. Let's do that. Because of space, I'll need to rub that. So variance is given here by, no, we want to first of all get mean. Sorry. Mean is given by assumed mean plus summation of FD over summation F. This implies that A, which was 50, plus summation of FD, we needed this sum. I hope you can add them. Let's get this sum of FD. It's coming to 507.5. 507.5. 507.5 if you add these values. If that is it, then it's 50 plus 507.5 divided by 55. Why 55? 55 is the number of entry, the number of students that we have in this class. So at the end of the day, we have 507.5 divided by 55 gives you 9.227. Then you add 50, you are getting a mean of 59.227. So your X bar or mean is normally represented by X bar. It's given by 59.22. The mean score of that class is 59.227 marks. Now we can say confidently that this class performed better than the previous class that had a mean of, the previous class, you remember it had a mean score of 50. That was a Form 4 class, and possibly we can argue that the content in Form 4 is harder than the Form 3, but this Form 3 class has done better than Form 4 class. And look at this. These are more students than the 35 we had calculated in example 1, but yet they still end up having a better mean score. So really, we can argue that the number of candidates or the increase in number of candidates does not lead to decrease in the mean score of a school. And therefore, let nobody tell you we failed the exam because our class has many students. No, it simply means that each individual is not working hard enough to improve on their mean score. If everybody worked, everybody did their part, you will end up with a better mean score, a higher mean score. Good, that is mean score. Now variance, because we have already calculated, filled in all these columns. Hope you've noted that. Variance, we had already indicated the formula, and therefore variance is given by summation of FD squared, which is 18,000. Yes, 18,000. We have it there, 18,253.75 divided by 55 minus, sorry, not plus, minus, it is well indicated on the slide, minus summation of FD, that is 507.5 over 55, this squared. 507.5 divided by 55, then you square that. Once you work this out, let's work this out. Take your calculator. 18,253.75 divided by 55. That gives you 331.886 minus 507.5 divided by 55. That gives you 9 point, you square that. Answer squared gives you 85.143. So if you work this out, you are going to get the variance. So we are simply saying 331.886, you less 85.143, and you're ending up with 246.743. This is your variance. This is your variance. As the word suggests, variance means varying from the mean. The varying from the mean. Possibly it does not make a lot of sense, but when we go to the next step after this, which is standard deviation, which is again very simple to talk about, I think it's important to mention that standard deviation, I could just write here that standard deviation, SD, is given by the square root of variance. Standard deviation is normally given by the square root of variance. So simply what we are saying is that SD is given by the square root of 246. So if I get square root of 246.743, I'm getting 15.7, 15.70. That is my standard deviation. Simply means that our mean score, which we already found out as 59, we are 15.7 steps or standards away from the mean. The spread from the mean is 15 steps. We can say you can go left 15 steps and you can go right 15 steps. So basically what we are saying is that the spread of this performance was wide because 15 steps are many, and therefore if this class is to be talked to in terms of performance, the teacher need to tell the students that have not performed well to pull up, to come close to the mean, because they are 15 steps away or 15 standards away from the mean. If you look at that spread in the distribution table, you can notice that it's only a few that are top scoring. Between 80 and 99, we have 6 students. And again, between below 49 or below 50, say that below 50 we have 16 students. That means the tail is bigger. This teacher needs to work on the tail, or this class needs to work on the time takers to improve or to push it forward towards 59 as our mean score. I think having said that, class, you will agree with me that you can easily work out the mean using assumed mean. You can easily work out variance using assumed mean. And finally, you can calculate your standard deviation, because we are saying again, standard deviation is given by standard deviation is given by the square root of variance. Square root of variance. Possibly you can do one more example if need be, or I could give this as your takeaway assignment, because you need to work this out. before I give the take-home data, yes, I have it here with me. Before I give the takeaway assignment, I want us to agree. That anytime you want to work out the mean, you only need to look at what the examiner or what the teacher has given us as the assumed mean. From that assumed mean, we can calculate our deviations as indicated here. Once you have your deviations, you multiply them by their respective frequency. You've got to be very keen, students, as you multiply these values, because sometimes there is mix-up. You can notice that some of them are negative, some of them are positive. You need to keep your eyes on the numbers, sometimes just to avoid some silly or careless mistakes. Once you get your sum of product of frequency and deviation, then you are good to go. Your mean is given by A, as we had said. Mean is given by A plus summation of FD over summation F. This is our mean using assumed mean. Our FD sum is given here. Our assumed mean was already given in the question. So having said that, I think these are free marks to gather. Then our variance is given by the summation of FD squared. My emphasis here, I must emphasize on this. It is the D that you square first. Once you square your D, then you multiply it by the frequency. You don't, some students make a mistake of squaring FD. If you square FD, you are simply squaring frequency and deviation. That's a big mistake. It is the deviation that have been squared. Why are they being squared? Class, they are being squared to get the absolute value. The intention is to get absolute value, so that once we take the square root, we go back to the original values. Because while they are at negative, they may not represent the measure very well. But once you take squares, you are dealing with them as absolute. Values. So you are squaring your deviation, then you multiply that with frequency. Then you get a column called FD squared. Please notice it is D that is squared only, not F. F is not squared. Once you get that, then the variance is given by summation of FD squared over summation F minus summation of FD over summation F, that squared, you get variance. And finally, standard deviation is simply the square root of variance. Standard deviation is very simple. It is the square root of the variance. Having said that, I think I can give one more an exercise that you can do at home. I want to give an exercise that you can do at home. We want to write it down very fast. This is your assignment, a takeaway assignment. The distribution of English marks for Form 4 students in Bungoma High School is given in the following table. The distribution of English marks for Form 4 students in Bungoma Boys High School is given in the table below. Here we go. I always prefer writing the table in this form to save on time, because if you write it in landscape, you'll still be forced to rewrite it in portrait form. Here we have the marks. These are English marks, 1 to 10. 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, yes, 61 to 70, 71 to 80, 81 to 90, and then 91 to 100. Then the frequency are as follows. Allow me to subtract them for you because what they have given is cumulative frequency and I don't want to tax you into that. So 7 minus 2 is 5. And 16 minus 7 is 9. And then 28 minus 16 is 12. Forgive my 9. It looks like a G. Then 53 minus 28 is 25. 90 minus 53, 37. 101 minus 90 is 11. Then all right, well noted. 11, that's between 60 and 107 minus 101, that is 6. And 2, and then finally 1. So there are 110 students in Bungoma High School Form 4 class. Their marks in English exam were as follows. Then the question is, taking A assumed mean as, by the way, as I give this assignment, I need to mention something to do with assumed mean. It is any mark. It is any mark. But again, you can't take 1 as assumed mean. That wouldn't look wise of you. Why? Because if you look at this distribution, the mean must be around the center. So even me as a teacher, as I pick my assumed mean, I'm picking it around the center. I have said it is any value. You can pick literally any value. But to apply some wisdom, you need to pick a value that is around the center. In this case, if you agree with us, we could take 55. We could take 55 as our assumed mean. So taking A as 55, find mean and variance. Find mean and variance. That should give you, or rather, let's doctor that to read. Find the mean, variance, and standard deviation so that you earn your 10 marks. These are free 10 marks. What I have taught in this one lesson earns you 10 marks. 10 is a marks. Taking A, assumed mean as 55. Find mean, variance, and standard deviation. Your A assumed mean is 55. Now, I have picked a question from one of you. They're asking, is the column of D a must? D is deviation from assumed mean. This column is very important because if you don't use the column of D, then you are using the other method of looking for mean. There is another method. I already said that. And I had said that mean is given by mean, which we indicate as x bar, is given by summation of fx over summation f. The other method that I keep saying, the other method, is simply getting the midpoint multiplied by frequency. Rather than get this column of D, here you remember we have midpoint first. So you can decide to get fx. Then summation of fx is here, what we have, and summation of f, which is 110 here, is what we have. But this is not the method we are discussing today. We want to look at mean using assumed mean. That's why I'm saying the deviation column is important, and it is given by midpoint minus assumed mean. With that assignment, I am sure you'll be able to get to exercise what you have learned today. As I've always reminded you students, mathematics is a doing subject. It is a science subject. You've got to keep doing them. Do not look at them. Do not scan and say, I think Mr. Maina taught me this. I'm good to go. That may work against you. The way out is going to different texts. There are many writers that have written about statistics too. Go find out what they are saying. Go work them out. Most of the books have answers provided. Find out what do the other authors say about statistics too, especially on mean using assumed mean. So with that, some people will ask, why should I get bothered to look for, to work out statistics? Statistics, as I had said in the beginning, the application has a wide range in the market, especially the companies. Any market, any company that is serious and want to do marketing, they must take statistics of their client first and know, if this is my product, on average, in this target market, how many people am I likely to attract? Otherwise, suppose you are producing, let's say you are producing soda, and your target group is old people. If you take statistics from them, I want to assure you that business will not peak. Because if you just go and do business without taking statistics, you will have a big fail. Reason because most of our older generation will not prefer soda. But if your market target or your target market is the young people, go do statistics with them. You realize that you are in for a big business. So those statistics are very important, and they are this simple. You need to get the average, that is what we are calling the mean. You need to get the variance, how far are we going away from this mean, and so on and so forth. In the performance of any company, it is measured by statistics. Performance of any company is measured by statistics. Performance of every individual is measured by statistics. They'll tell you, look, we gave you this capital at the beginning of business. This is how much you have been able to bring to the company on average per year. Then, are you helping the company or not? And because, as it has always been pointed out, this education prepares you for the work, for the labor market, then you need to understand how to work out statistics. Now, even closer home, statistics is applied. If you look at the population today, many families have how many children per family? They range from 1, 2, 3, at most 4. That is the trend today. You should ask, why is that the statistic? Why is the mean children in a family 3 today? Possibly you can quote cost of living. Possibly you can quote cost of education, and so on and so forth. But in that, you are dealing with the statistics. In that, you are already dealing with statistics. I don't know whether there is one more question that we can handle as we come to the end of the lesson, because we have talked about much of what we ought to have talked about. But my emphasis again goes to the approximation. You noted that when I was writing the answers, I was very keen to write many decimals. Most of our students end up doing what we call premature approximation. and they are approximating in the columns, you should not round off your answer until the very final answer. You should not round off your answer until the very final answer. That's what we are insisting, so that you don't lose your marks carelessly. In the exam, we write for you PA, and people, most of you students come asking me, Mwalimu, what is PA supposed to mean in my exam? This is premature approximation, and it denies you marks. So what we are saying, carry all your decimals, then the last step, the very last step, that's when you approximate. And that's what to say, especially in statistics, where values are very, very keenly looked at. The other emphasis that I need to put, apart from premature approximation, I think I have already talked about the D squared. It is the D that we square, not FD. It is the D that is squared that then we multiply it by F to get FD squared. There is a difference between FD squared and FD squared. These are two different things, class. In this case, it is only D that has been squared. F has not been squared. But in this case, both F and D have been squared. Having said that, the last bit that I want us to say is that whatever we have discussed today is called measure of, whatever we have discussed today is basically a measure of central tendency. What we have discussed today is measure of central tendency. It measures the spread because, again, any data must achieve a normal distribution curve. Any data that is well collected, that is well meaning, must achieve normal distribution curve. So basically what we have done, we have discussed measure of central tendency. So in the next lesson, I'll be talking to you about the measure of dispersal. In the next lesson, we shall be discussing measure of dispersal that involves the quartiles, the deciles, the percentiles, the quartile deviations, and the ogive. All those, what we call median, those you already have heard about them. Those are the things that we shall be discussing in the next lesson. Otherwise, I think you have understood what the lesson intended to achieve. And from now on, you can work out, especially this question on Bungoma High School. I want you to work on it. Give us the solution so that we see whether you have learned what we intended you to learn. And as we wind up, we still want to insist. Revision. Revise these questions. This is, as you've seen, this is 10 marks. This is a section 2 question. If you don't know how to do these statistics, then you'll have very few options in your section 2 paper. And that will narrow down your grade. So I am urging us, because this is not a difficult topic, let's indulge in it. Let's do more. Let's dig into books, get more examples, and solve them, and see whether we understand what goes on around statistics. Having said that, I wish you well as we continue to prepare for end of term, end of year exam, that is KCSE exam. Even with the coming of the rains, we know that you can keep safe so that you advance your career, especially in statistics. Statistics is one of career subject. You can go to the university and do statistics as your career subject, so don't take it lightly. And for your information, statistics is a compulsory unit in all the courses. Even if you want to do journalism, or what other course, just know that statistics is part of what you will learn in the university. Having said that, I wish you well, and let's continue revising.